Okay, lesson 9.2 is theoretical and experimental probability. So before we get into what theoretical and experimental probability means, we need to talk about what uniform probability is. So in a uniform probability model, each outcome has an equal probability of happening. So if you look at A versus B, which wheel has uniform probability? Well, it's wheel A. Because if you look, all the sections are the same exact size, where wheel B, the winds are way smaller, so there's less likely of a chance that we would land on the U win. We would more likely win or land on the U lose if we were to spin that. Theoretical probability is based on uniform probability. So what we just talked about, if it is all like the same likelihood of happening, that is uniform probability. So theoretical probability is based on uniform probability. What should happen when conducting a probability experiment? So this is all theoretical. If you think about it, the base word is theory. Your root word there would be theory. So it's in theory, if we were to spin this spinner, what's the probability we would get that land on a 6 or whatever? Experimental probability is based on relative frequency, which means that you've already done it. You've already done the experiment. What's the probability that if you do it again, you'll get the same thing? So what actually occurs during such an experiment? The theoretical probability and the experimental probability of an event may or may not be the same. Sometimes you'll get a theoretical probability and then you'll do the experimental and it'll be way different answers. As the number of attempts increase, the theoretical probability and the experimental probability should become closer in value. So if you say spin a spinner 2 times, you're not going to necessarily get the same thing. But if you spin it 15 times, you could be getting a little closer to theoretical versus experimental. If you were to spin it 500, your experimental might look the exact same as your theoretical, because the more you spin, the closer you're going to get to your theoretical probability. If there is a spinner with 3 equal sections, what is the probability of spinning a red, blue, or a green? Now in this, they don't clarify. Are they asking for theoretical or experimental? Well, we can know that because it doesn't say Sally has performed an experiment where she's spun a spinner with 3 equal sections. We know that therefore it's in theory. If it doesn't give us an example of something that's already been done, it's a theory. So the probability of getting a red is 1/3 because there are 3 sections and there's 1 red. Probability of getting a green is 1/3. And probability of getting a blue is 1/3. So it's 1/3 because there are 3 sections, one of the sections being those specific colors. 1B, the graph shows the results of an experiment in which a spinner of 3 equal sections is spun 60 times. So find the experimental probability of each color. So we know that it was spun 60 times, so there were 60 possible opportunities for it to land on red. And if we look at our table, it landed on red 24 times. We know that this can be reduced. We know that 12 goes into both of these numbers. So we take 24 divided by 12, which is 2, and 60 divided by 12, which is 5. So the experimental probability is 2/5. Green, again, it was spun 60 times. I should be doing in the colors that match. It was spun 60 times. And on the spinner results over here, it landed on green 21 times. We know that 3 goes into both of these numbers, so we take 21 divided by 3 is 7, and 60 divided by 3 is 20. So we have 7/20. We circle it, and that's our answer. And for blue, again, it was spun 60 times, and it landed on blue 15 of those times. And I'm not sure. I think 15 goes into 60. Evenly it does. It goes in 4 times, so we divide by 15 and we get 1/4. So these are based off of the results on this graph right here. So therefore it's experimental because it's something that's already been done. 2 number cubes are rolled together 20 times. A sum of 9 is rolled 8 times. What is the theoretical experimental probability of rolling a number or rolling a sum of 9? So to find the experimental, it's easier. Then it kind of already gives it to us. So let's go ahead and do experimental first. So to find the experimental probability, you're rolling the dice 20 times, and you get a sum of 9 8 of those times. And then we can reduce this. 4 goes into both, 4 goes into both. And so we get 2/5. We circle it, and that's our answer. Then to do theoretical, we think of all the ways that we could get a sum of 9. And so that would be 4 and 5, or 5 and 4. So, or we could get a 3 and a 6, or a 6 and a 3. So there are 4 different combos we could get. So when we're rolling the dice, when we're rolling the 2 dice, there are 36 possible outcomes between the 2 dice being rolled together. And there's 4 different ways that we could get a sum of 9. So that's 4/36, which reduces to 1/9. So we circle it, and that's our answer. So you can see that we have a different experimental versus a theoretical here. Last year, DVD stores sold 670 action DVDs, 580 comedy DVDs, 450 drama DVDs, and 300 horror DVDs. If a media buyer expects to sell 5,000 DVDs this year, based on these results, how many comedy DVDs should she buy? Explain. So she's expanding her DVD selection. She's going to hold 5,000 DVDs this year compared to the 2,000 she held last year. So she's trying to figure out how many comedies she should buy if, based on the probability from last year, the experimental probability from last year, she uses that number, assuming that customers will buy the same number of comedy this year. So last year, out of the total 2,000 DVDs, and I know that because I did the math ahead of time, and I added 670 plus 580 plus 450 plus 300 is 2,000. And of those 2,000, 580 were comedies. I reduced that to be 29 over 100. So if we're setting up a proportion, which we're going to because we have 3 items and we need the 4th, we're talking about comedies versus total number of DVDs. So if we have 2,900 over 100, could I use 580 over 2,000? Yes. Do I want to? Absolutely not. I don't want to do that much math. She's buying 5,000 DVDs, so we need to figure out how much of the 5,000 should be comedies. So we cross multiply, and we get 29 times 5,000 is 145,000. And 100 times x is 100x. We divide by 100 to get x by itself. So x equals 1,450 DVDs. We circle it, and that's our answer.